Hello, mentors. Let's look at an example of a round of this game of this turtle eggs. And let's say in this round, we have these three habitats: average, the minimum habitat, which is a very dangerous one, very, very hard. And finally, we have random. So the first thing players do as a team is they decide the goal. In order to do that, you should say that, of course, the numbers will be, by rolling two dice. So it's between 2 and 12, right? And then they'll place those numbers secretly with tokens. So, let's say that 36 would be a number, meaning 12 for each. That's way too hard. So, but players are still, ambitious in this round. And let's say they say, okay, let's pretend on average that we're gonna get 10 on each of these habitats, 10 eggs to hatch. So they go for 30, right? 10, 10, 10. So there's some disagreement. Some players say, let's go with 25, and some others say maybe let's go with 20. Very conservative, right? But at the end, they decide 30, and they say, okay, this is just the first round, a trial round, let's say, and we'll just test it out. Okay, what happens next is secretly after rolling the dice and looking at the numbers they roll, all these players place their different tokens representing their numbers, the secret numbers, on one of the places. So in this case, we have 3, 3, and then 2 for random. What happens is if no player puts any token in a habitat, so if a habitat is empty, that will mean 0 points. So you should encourage at least one player to put one token. But that will depend on your strategy. We'll see that sometimes it's better to leave some empty maybe and go for others, because boards can be really crazy. Okay, when all these players are done in tokens, each will replace their token with the actual number that they roll. So of course, no cheating here. It's really important just to have this culture. And then let's say this was what happened. So we had 10, 7, 4, a couple of 9s, a 10, a 12, and a 2. So we will need to reach 30 or more. But first, we have to solve all these boards, all these habitats. So first, we compute the average in this average habitat. So we just add 10, 7, and 4. That's 21 divided by 3. That's a 7. So that's the average there. The minimum here is easy. It's between 9, 9, and 10. So that's 10. And probably, these players had high values. They pick it in the minimum, hoping that nobody would ruin their scores. It would have been really bad if just one of the players would have put a 3 here, say, because then the minimum would be 3 and somehow the 9 and the 10 would be wasted. So that's a mathematical notion of the minimum, that the minimum, only takes into account one of the numbers, whereas the average take all of the numbers, weighting the same. So it's a little more fair in that regard. But let's go back to this. Let's say after randomly picking between the 12 and the 2, players got really lucky and got the 12. So probably the player that picked this number 2 was hoping that many other players would put much higher, numbers, and then randomly it would be good. In this case, it was a 50-50, and hopefully, luckily for him, didn't happen. So we get a 7, a 9, and a 12. Those are the values of each of the boards, and then we add. And when we add, of course, we got very close, 28, not 30. So we get 0 points. So the game, is pretty bad in this regard. Like, pretty mean because, you didn't get to that. So of course, in retrospective, players would have said, "I told you, maybe we should have put 25 or other things." Now let's analyze a little bit, and then the next round will start. But let's analyze a little bit beyond the score. How else should maybe the players could have played? And so, for example, we could see that, the minimum is good, but it's a little risky. So maybe let's just say that this player that picked the 10 here would have played here. What would happen to the average is that it would have been 20 plus 7, 27, plus 4, 31. So the average would be, pretty much 10 0.3, and then you would get a higher value. So that, of course, in retrospective, it's very easy to say. Random is really hard because no matter, I mean, even if this 9 would have been moved here, if the player would have put this 9 here, random would still be 12 or even less, right? If you pick the 9 or the 2. So that wouldn't be a very good thing. Now, what would happen is that this 4 here, it's also hurting here if you put the 4 here. So maybe if you put it in the random and hope for the best, hope to get a 12, then this average would be a little bigger because then it would be 27, right? Divided by 3. And so 27 divided by 3, of course, it's 9. So it's still big. And then you would get to 28, right? So, well, more than 28. But anyways, I think it's important to encourage those what could have been if I play different right after ending the round instead of just going to the next round. Just play, move the tokens, and what would have happened if this or that, because that's what really starts helping students see what's the effect of changing just a number in computing these data functions like the average, the random, etc. So that's the game. Final recommendation is when you're explaining the rules, don't go through all the habitats at the same time at the beginning because there's too many. Just go with the rules, with what the manual says about, first round, it's these habitats, then it's these other habitats, and just go from there. You can pace it and you can, adapt it. If you feel that students are really picking it, then you can add another habitat. Or if you feel that they're still not understanding, then play the same boards or the same habitats again in a sequent round. So that's the game. And hopefully you have fun. This is part 1 of the meeting, and it's supposed to be around 50 or 45 minutes or so. So it's gonna be a long game. Enjoy.